All right. Welcome back to Prime Mover. I'm gonna move some primes. Let's see. All right. So, transistor. If A is positive, positive 1, we're gonna send C to B. And if A is 0, we're going to delete C. So, we're gonna have something like so we'll lock C, right? We'll lock C like right here. And then we'll have something like this, right? So we're gonna lock C here. And if A is 1, so this is kind of similar to what we just did. So I'll show you that low control, right? So remember we had C, okay, let me go back to the instructions. So if A is 1, so depending on what A is, we're going to either send B to D or C to D. So we locked C and we locked B. And then if A was 1, we'd send it over here. It'd unlock this. A would get deleted, right? If A was 0, it'd go this way, get deleted, and it'll unlock here. So same concept here. So we're going to lock C. And if A is 1, we're going to send C to B. And if A is 0, we're going to delete C. So we'll have some kind of button here that will switch this. Now, remember the property of this. Anytime something passes over this, this switches automatically on its own. So we might need to adjust this somehow. So maybe instead of having it get it deleted immediately, it'll pass through this button and then get deleted. In any case. So if A is 1, so A is either only going to be positive 1 or 0. So we can use this with the negative pointing to the left. Because if there were negative C, it would shoot back out to the left and break everything, right? But we don't have to worry about that. So if A is negative, or sorry, if A is 0, or if A is 1, we're going to send C to B. So if A is 1, first we need to unlock this button. I guess we would do that after. So I'm thinking I might have to slow down this somehow. So might have to do something like and obviously this is not the most optimal solution as far as using the least amount of chips or the speed, but this is just to help just have to come out the right side here. I'm gonna do this. I'll put the lock here. And then I'll put the unlock here. And so the inputs will go through here. I feel like I should have it like really close. I guess I can have it all the way left. That's fine. We'll have that unlocked. We'll have the button here. I'm gonna try and use these hotkeys. 8. I need a 9. Alright, so the inputs are gonna come here, pass over this, that'll automatically lock it. And then they'll pass through this button, which will unlock the next input. And then have it come out the right side. So this is just, I can worry about if I need this or not later. So, okay. So that'll make sure we only have one input at a time, so that's nice. So now we got to worry about this. So we need to delete C if A is 0. So we'll have this default to up, I guess. Or I guess we don't have to worry about that right now. Let's think. How should we do this? So if A is 1, we probably just have it go there, right? We'll just start with that. We'll do something like this. So this can cross over, right? So if A is 1, we'll say we'll have if A is 0, and then we probably just delete A as well. After. So if A is 1, it's gonna, obviously this input from C is gonna go here and get stuck. A will then, I need to unlock this first, or maybe second, I don't know. So let's do, and obviously this, again, not ideal solution at all. So this is a duplicator, so it'll take the input and then send one out this way and one out this way. So there'll be a button here. Oh, whoops. So this button, and we'll do some slow wire here to make sure that it goes the direction, the track is facing the correct way first, and then the button is pressed. And I might need another button here, something like this, because remember this will change directions every time something passes over it. So this kind of resets it back to the correct direction, if that makes sense. I think that's how that works. So A is 0, right? So if A is 0, what happens? C gets locked here. 2 inputs will come through. This one should come through first because this purple is slow wire. So the 0 will come through here. And we want, if A is 0, we want to delete C. So I'm sure there's a much better way to do this. So for okay, let me back up. Let me back up a little bit. I got a whole lot of stuff going on. All right, so we need to lock the inputs, that's for sure. We need to sort. We need to sort the inputs. So we don't need to sort the unlocking part. So that's fine if that just comes straight down. So if the A is 0, we want it to flip a switch. Or don't flip a switch. If A is 1 or positive, right? We want to send C to B. Okay. Perfect. Okay, so we can work with that. So again, we'll have this duplicated input is going to come down and unlock this button. And we want the track to be facing the correct direction before it gets here, so that's why I'm putting slow wire here, right? If this was too fast, it might unlock it and then go the wrong direction first. So if if A is 0, C needs to get deleted. So we can have it such that every time... So let's just assume inputs are going here, right? So the way this works is, ignore the lock for a second. Inputs come along this, and it's set to the left. So it'll go to the left, and then this will switch. And so the next input that comes along will go to the right. So what we can do is have a self-correcting switch, right? So every time something comes along this way, this will switch, and then the input will hit this button and then switch it back. So every time something comes along this way, it'll always stay pointed to the left. Okay, so that's big. That's tech, right? So this is a always left switch, right? And then if something goes to the right, we don't want to put another switch here because we don't want it to stay right. We actually want it to go back to left. So it's always going to default to left, right? So what this means is if A is 1, we actually don't have to do anything, right? This is already set up for 1 to go through. The only time we have to do change this track is if A is 0. So if A is 1, we can just go ahead and delete it, right? So remember, our input's going to come along here. This is going to lock after the first one. It's going to hit this button, which is going to unlock the next input, right? I'll put some slow wire here, so it doesn't come through too quickly. So input's going to come along, hit this button, unlock the next input. So inputs are always going to be feeding through. It always locks after the first one. The button unlocks the next one. And then it's going to get duplicated here. I'm sorry, I need to... turn the music down. Alright, so this is already set up for A being 1 or positive or on, whatever you want to call it, right? This is already set up for that. So all we have to do here is send that input to B. And then we're going to have to do probably one of these. So if A is 0, we need to switch this track. So we're going to have a button here. And then we just delete it. So here's what's going to happen, right? The inputs from C are going to go here and get locked. They cannot move. The input from A, if it's 0, an A input is going to come along this track and unlock this button eventually. And then an A input that's 0 is going to come along this track, hit this button, which toggles it to the delete, right? So this is switched to delete. Then this will unlock. Then the C input will get deleted. The C will lock again. And then as something passes over to the right, this should automatically go back to the left, right? Now, if A is positive 1, the positive 1 gets deleted here. And what'll happen is the duplicated input will come down along this track and unlock this button, right? And since this is already pointed to the left and nothing's traveling on this path, this should, the C will get unlocked. It'll go along this path. This will switch. It'll hit the button, so it'll switch back, and then it should just go. So I think in theory this works. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, Okay, so the 0 is too slow here. Okay, so let's look at what we got going on here. Okay. So we can fix that. We just want the shorter path to be to the right. So we'll have the button thing like this. The lock here. Unlocked for the first one. Right. So that should work. So inputs are going to come along here. The first one we'll get through and then lock this. This button should unlock the next one. It'll get duplicated and come out the right side. And since this is a longer track, it should come out the left side slower. So let's try that. All right, first input gets through. Boom. Gets duplicated. Lets the next one through. Now this one is first. All right, so it's a 0 input. So 0 should switch this track to make it go to the right. Boom, switched. Gets deleted. And then now this will unlock and then get deleted. Okay, so two things. This is a little too slow. And then secondly, I forgot to do something about the input that goes over here. So this this has got to get deleted. Okay, now this should be a working solution. Right, so this is coming through here, and then in a few seconds we should have one come down here. Perfect. Right. Boom. Track is switched. And then, subsequently, the next one is unlocked. Or the C input is unlocked. The A input is deleted. C input gets deleted. The A input was a 1, so that already got deleted. Right? So this is going to unlock the next one. It's on the left track, right? Track gets switched, but the button gets pressed. Track switches back. Perfect. And we'll just let it play. Perfect. All right, so I did it in, and again, just for anyone who's watching now for the first time, I played this game before, like 10 years ago or something. I'm starting on a new save, but my records are still in here, so this is the best amount of ticks I've done it in, apparently. But at one point I did it in 11 ships, and then Race is just a friend of mine. Do we want to try and optimize this? I kind of do. So I like this locking mechanism. I definitely don't feel like you need the duplicator. I think the self-correcting track is probably, you definitely need these two parts. So what I'm trying to do it in less ticks, right? So we definitely need some kind of locking mechanism. We'll put it here. We need a way to unlock the mechanism. We need a track. Need the self-correcting button. We might not need the self-correcting button. If we want to lower the ticks, I feel like we probably do, but there's probably a way to do this without, if you want to do less chips, right? Because the button counts as a chip. There's a way to do it without that, I'm sure. You know, just have the A input hit the button every time instead of, anyways, so we'll do something like this. So both inputs need to unlock this button. Dang, maybe we do need a duplicator though. So for sure we'll do this, right? For sure anything that unlocks this needs to get deleted after, right? And this is in the lock position at the beginning. That's good. But boom, gets unlocked, gets deleted. Perfect. So we know that works. Now we need a sorter, right? So what this will do is if it's a 0 input, it should come along here and activate this button. We're kind of going with the same solution I had last time, just like a faster solution, right? This will get deleted. Connect those. So these are the A inputs for 0 or 1, one of the two, getting deleted. And then obviously you can pick, like you can have it default to this, right? And then have the 0 inputs get deleted and then the positive ones come along here. I can't tell you if one is particularly faster than the other. Anyways. So we'll just keep the same solution we had before. So this is the self-correcting switch. This is the switch for 0 inputs. So again, we can just delete the 1. And if it is 0, we can do it. Ooh, do this, I guess. So that should work, and then we might just have to do some slow wire here to make sure, because obviously this is a longer path than this, so maybe I could put the button. Can I do that? Have this on that side so I don't have to slow it down with wire, because we want, obviously we want the correct path to happen before the unlocking of the C input. So if I move this over here, it's probably a way to like, so you can select this and mirror stuff. Click middle mouse or press R to rotate. Yeah, maybe we could rotate this, but we'll just try this for now. This should be faster. So 0 input. Oh, we don't have any locking mechanism though. Ooh, this might be a mess. Yeah. Yeah, that didn't work. Okay, yeah, we might need some kind of locking mechanism then. Dang, okay. I really wanted to avoid it. That was like my main way to make it faster. Otherwise, this is not just the same solution I already had, pretty much. Okay, so let's scrap this, and then we'll copy this, paste it here. So let's see if we can so it was press hold middle mouse or press M to mirror. I'm not. My brain is not large enough to use that feature. So basically what we want is we want this input to be quicker to get to the unlock. So we need to just put the unlock closer to here, right? So we'll say, or the track switcher, sorry. So if we put the track here, enough space. We'll put the unlock Let's have this face this way. I mean, you could even do this, no? Would this not work? No, it wouldn't. Let me put it here, here. Then we need a button. Self-correct. This is probably less fun to watch than watching me solve a new puzzle. Maybe I'll just kind of go through other levels first and then worry about optimizing later. In any case, here we are. So positive inputs are deleted. By default, it's going to the right and then self-correcting. If we have a 0 input, we'll have it hit this button. And then can I do this? Oh, that saves chips too. No, I can't do that. Okay. Oh, what did I do? Wait a minute. Wasn't supposed to happen. Okay, I can't do that. Sweet. Ooh. Brain is small. Alright. So that works. Boom. Got the locking mechanism there. And we might not even need the lock. So this, if it's if A is 0, this is going to get deleted. So it's going to hit this. Boom. Okay. So if it's positive, it gets deleted, track stays the same. If it's 0, the track switches, and then that'll get deleted and then automatically switch back. So that should take care of that. Now we just need to... What do we need to do? Wait, do I even need this? Oh yeah, I have to unlock the input. That's what it is. Okay, I'm like, I'm missing something. So this will make the track be correct. So we'll kind of play this frame by frame here. Or step by step. Alright. So the locking mechanism is obviously still working fine. That gets duplicated. It's a 0, so it needs to switch the track. Perfect. Track is switched, and then that A input is deleted. And then now, this next 0 comes through. Where are we at? The 1 is still in the queue, thank God. Alright, next input is unlocked. Perfect. Next one is going through. It's a 1. So we know it works for 0. Does it work for 1? Oh. I gotta delete the inputs. Alright, so that should work. Let's go! That was not any faster. Alright. Yeah, well. Here we are. Okay, what is this? We got a purple landscape. Some tech. Okay, some people worshipping. Such a cool game. Yo. What is that? Is that a beacon? Is that a bomb? Was it a... Seen that V before. Alright. AND gate. You know, if you knew computer science, this might be an easy game. Perhaps. Or easier. AND gate. So if both A and B are 1, we need to send 1 to C. If not, we need to send 0 to C. Both A and B. So A and B are both only 0 or positive ones. That's nice. Ooh. I am starving. Need to make some food after this. Okay, so we need to differentiate between a 0 input and a positive input. So in the case that A is B, or A and B are both 1, we need to send 1 to C. So if A is 1, we'll check if B is 1, right? My whiteboard, my dry eraser. So anyways, think out loud. So if A is 1, first we're going to check if A is 1. If A is not 1, we'll keep that input. So we're gonna keep the A input no matter what, right? If A is 1, we'll then check to see if B is 1. If B is 1, then we'll delete B and just send that A input to C. If A is 1 and B is 0, we'll somehow switch the track, right? And so A will, we'll keep A. B will switch a track and then get deleted, and then A will get subtracted to be 0. So we'll have an A input that's 1, B is input's 0. The 0 input from the B is going to switch a track, right? The A will then go on a track that will subtract 1 from its total, and then go to C. In the case that A is 0 and B is, well, I guess we don't have to check what B is if A is 0. Because if A is 0, we just send a 0 to C. B gets deleted. So first we'll have some kind of, probably need to have some kind of locking mechanism. How do we want to do that? What's the best way to do that? This is not the most efficient way to do it, but this is just what I'm going to do. So we'll have, obviously, a lock and a button. And it'll be unlocked. Now we can copy this. We can go here, we can go here, and then we can hit M to mirror. All right, so now we have, we'll just do 2 wires here. So we'll have our inputs come from here, right? Now again, if A is 1, oops. If A is 1, I'll have it come out this way. Actually, I want it to kind of go down. I think there's more space. So if A is 1, we will then check to see if B is 1. So if A is 1, we need to somehow check if B is 1. So let's just try this in steps, right? Make sure this works. Boom. Okay, that works. So we got numbers coming out. A and B are both 1. So in the case that A and B are both 1, we could have nothing happen, right? So we'll do something like this. See, we're going to need 2 of these. Don't ask me why, I don't know. So if A is 1, we can check if B is 1. This is going to be a slower solution, but I want it to be that I want there to be no chance of anything going wrong. So here's what I'm thinking. Best way to do this. I'm going to go in from the top here. And I don't know. I genuinely have no clue what I'm doing. So I just I want the input to come unlock these buttons, basically, I guess. So I'll have like a duplicator here, right? And then get deleted. So after we have one final input that will somewhere get duplicated, so it'll go to C, and then it'll also go to here, which will unlock the next 2 set of inputs, right? These are both going to be unlocked originally. So we're going to have some calculations. We'll have a duplicator here. And that'll send an input. All right. I'll send an input to these 2 buttons, which will unlock the next set of inputs. So, okay. Now that we have the sorting mechanism sorted, we can work on, or sorry, the flow control system. I don't know. Actually, let's They definitely set this up so that they teach you. The early levels are supposed to teach you some basic fundamentals, and then you're supposed to use those fundamentals to do other stuff, right? We got a gate here. I might run out of time here. Start making some food and then go to work. All right, so what do we know? Basically, if A, we talked about this before, if A and B are both positive 1, we can just delete the B input. Or the B, instead of having a duplicator, we can just have the B input be the unlock mechanism. So the B can be the unlock mechanism. The B also has to be the indicator for whether A gets So, okay, let me do this. So let's just make this really easy. Obviously, B cannot be negative. So if A is 0, then we can go ahead and just send 0 here, right? If A is positive 1, we then need to check if B is 1 or not. So I'm gonna just have a chip here because I feel like I'm running out of space. Feeling claustrophobic. So we'll have B come along here, right? So B's gonna come along here. So we'll do the same thing we did not too long ago. Is it no cleaner? Well, what am I looking at? Oh no, this is transistor, sorry. So we're gonna do the same thing we did in transistor, right? Where we have C come along, B locked, and then we'll have 2 tracks, right? And then that track will either add 1 or you know, just keep it, or sorry, subtract 1 or keep it the same. So we'll have, you know, this whole setup. We'll have the self-correcting button. We'll have this button and then the delete, right? Oops. So same system, right? We have our positive input coming from the top here, and we're gonna lock that. Lock it right here. Now, ooh. Hold on. I'm gonna do this. So we're going to have our B input come in here. It's going to come along here, get duplicated, come out here first, and then it'll take a few more ticks to unlock the next set, right? And then I can even go a step further, make this slow wire. I could even turn this into another chip, but I don't think that's necessary. So we got all this slow wire, and then that's going to unlock the next set of inputs, right? So the next set of inputs should be taken care of now. In fact, we can just test it, make sure that works. All right. Yep, perfect. Boom. Yep, next set of inputs unlocked. Perfect. So perfect. Okay. So all that's taken care of. Now we need to sort this, right? So if it's 0, we're just sending a 0. Perfect. No notes. If it's 1, we need to check if B is also 1, right? So the way to do that is I'll have another chip here. This. We'll lock it, right? So it's locked right off the gate, right off the start. We got a lock here. And we got a button to unlock it. We'll go ahead and delete this B input. And we can okay, how are we going to do this? How are we going to do this? I feel like the way I set it up is really cramped. So if A is 1, or sorry, if B is 1, because A is already 1 at this point, right? If A is entering this location, A is already 1. We just need to check if B is 1. If B is 1, we just need to unlock B, or unlock the A input and have it send. That's all that needs to happen. If B is 0, we need to first change the track that it's on. We need to change the track that it's on. So we'll have the default track. Oh, oops. The default track will be 1. Does that work? So default track will be 1. We're only basically checking if B is 0. So we'll duplicate the input. We'll hit a button over here. And then we'll delete the input. Boom. So, oops. So the A input is coming along here, getting locked. It'll then get unlocked by this button. Unlocked by this button, and then from the B input, and it'll get deleted. The B input will also go this way. And if B is, I guess we'll just do it this way because it's already set up that way. If B is 0, we'll leave the track how it is, right? Oh, man. It's too tight. I don't want to put a chip inside of a chip. You can. You just keep doing it forever, but I'm worried about timing, you know? We only have so much time before this. this comes through, I guess I can just add another, again, more slow wire. But I don't want to slow it down unnecessarily for no reason, you know? I'd rather this part just gets faster. So again, if B is 0, we need to subtract 1. We need to subtract 1. If B is 0, we need to subtract 1 from the track. If B is not 0, shouldn't this be here? So we need to decide what it is. Two tracks. I feel like I don't have enough space. I guess I gotta do something like this. Okay, so what needs to happen is if A is, we already know A is 1 if we got to this point. If A was 0, it would just go here, right? Oh, we have a problem. Oh, we have a problem. I didn't see that. And I gotta stop streaming too. The problem is if A is 0, we still have all this going on. So B could be 1, it's switching tracks in there, and there's no self-correct in there because we're just ignoring it. So yeah, I'm gonna have to come back to this. Well, if anyone's watching, thanks for watching. I will be back. Y'all have a great day.